Welcome. In this video we are looking at binary math. So with binary addition you have to remember everything is ones and zeros. So we have two examples. The one on the left, which is 1, 1, 1, and we're adding 1 to that. Remember, with binary, 1 plus 1 does not equal 2 in the normal sense. So here we take this one and we try to add it to that one. It doesn't fit. So we change this to a 0. That's why it's 0 down here. We add to the next spot. 1 plus 1, can't do it. It adds to a 0. We do the last one. 1 plus 1 still can't happen, so it will be a 0. So we can always add zeros to these numbers to the left. So that's what we're doing. We're actually adding a 0 here in the fourth spot. 1 plus 0 does equal 1. So 1, 0, 0, 0 converted to binary, that converted to decimal will be 8. You can always double check this by taking your original binary number, 1, 1, 1, that is actually 7 decimal, adding 1 to that, and 7 decimal plus 1 decimal is 8 decimal, so it equals. In the second example, we have a 0 in the second spot. So we have 1 plus 1, again that can't happen, so it changes to a 0. 1 plus 0, we can do that, so it becomes 1. And that remaining 1 in the third spot isn't affected because we've already added the 1, so that is just brought down. So this becomes 1, 1, 0. If you take that number and convert it to decimal, it is 6. Again, we can always double check this by looking at the whole number, converting it to decimal. 1, 0, 1 in binary is actually 5 in decimal. 5 decimal plus 1 decimal equals 6 decimal, and that's what we have if we break it down into binary. So we can always double check our math. What about subtraction? Nice thing is, if we have the ability, if we see ones, we can subtract 1 from 1. So here, if we take 1, 1, 1, and we're subtracting 1, we can actually do that by just subtracting 1 from the first bits. That becomes 0, so the binary number becomes 1, 1, 0. If we're not sure, we can always do the math in decimal form. 1, 1, 1 converted to decimal is 7. 7 minus 1 is 6. Take 6, convert it back to our decimal. 0, 1, 1, 0 is 6. So what happens if there's no 1 in the first position? What ends up happening is we can start using the borrowing method. Can we subtract 1 from 0? No. Can we subtract 1 from this 0? No. Can we subtract 1 from this one? Yes, we can. So that becomes 0, and these all become 1. If we are not sure, we can take this and we can convert it into decimal and check. 1, 2. So this is going to be 4 minus 1, which should be 3. Take 3, convert that back to binary, and it does. So how does this work in networking? So we're going to look at an example of 192.168.10.0. If we are looking at how to subtract 1 bit from this, nice thing is we have 4 groups of 8 bits, so we're going to take just the last two, the third octet and the fourth octet, and we're going to break that down into binary. And we're going to minus 1 bit. Again, we cannot subtract 1 from any of the zeros. I'm going to draw a line over here. So we know these bits are going to stay the same. The 1 that we can subtract, the first one that we come across, we're going to change that to a 0, and all the other zeros become 1. Because again, we cannot subtract 1 from that 0, any of those zeros. We can only subtract 1 from that last item. Now what we can do is we take the number 0, 0, 0, 0, 1, 0, 0, 1, dot 1, 1, 1, 1, 1, 1, 1, 1, which is actually 9.255. The nice thing is we know that if a group of all ones, that is 255 bits. So we know if we take 9.255 and we add 1 bit, that does actually equal 10.0. So this is an example of binary subtraction. You know what? Just to make sure, let's do the binary addition. So again, we're looking at 0, 0, 0, 0, 0, 0, 1, 1, 1, 1, 1, 1, 1, 1, 1. We're adding 1 bit. Again, we cannot add 1 to any of those bits. We can only add 1 to a 0. The nice thing is we're going to draw a line. These bits all remain the same. The first 0 that we can add to, we will add to. I don't know why it's doing that, but let's erase that. First 0 we can add to, we will add 1 to, and the rest of the ones become 0. That now becomes, take the number, we convert it, 10.0 in our decimal form. Let's give one more example. So in the example I have, it's going to be 10.0.0.64, and we're going to both subtract and add 1. So let's go ahead and do subtraction first. If we are looking at, again, I'm only really needing to look at the 4th octet here, so I'm only going to draw out the 4th octet in binary. 0, 1, 0, 0, because that's in the 64 spot. 1, 2, 4, 8, 16, 32, 64. That's why it is just 0, 1, 0, 0, 0, 0, 0, 0. We are minusing 1 bit. We cannot minus 1 from any of the zeros. We can only minus 1 from the first one that we find. The nice thing is that leading 0 is going to remain the same. We take the 1, we minus out of that 1. Once we do that, all zeros to the right of the 1 become 1s. 0, 0, 1, 1, 1, 1, 1, 1. So this is 64 minus 1. This, if you do the conversion, is 63, and that is correct. If we are looking at addition, 0, 1, 0, 0, 0, 0, 0, 0, add 1. We can add 1 to a 0, so we can do 1, 0, 0, 0, 0, 0, 1. That is 64 plus 1 equals 65, and that works. So those are some examples of binary addition and subtraction. If you need any assistance with this, please let me know. This is actually really important when we get into subnetting. Understanding how to add and subtract bits from full groups is very important. If you have any questions or concerns, feel free to reach out. Thank you.